Okay, this is an ASUS power supply, 19.5 volts, 9.23 amps. It was basically used for gaming laptops. You can use it for any purpose requiring 19 to 20 volts. Since I already opened it because it was faulty, it was basically dead. This was its cable. Let me show you what was inside. This is what I found inside. It's built very heavily, double-sided PCB. This is the secondary side, this is the primary side, and I already replaced the faulty MOSFET because this MOSFET on the secondary side, for synchronous rectification there are MOSFETs instead of diodes for synchronous rectification, because it's not simple rectification on the secondary side. It is using synchronous rectifiers controlled by maybe these two chips. Okay, after fixing the power supply, I thought maybe I can change its output voltage. So I'm partially successful in that, because the voltage I can change it from 19.5 volts to downside up to 12 volts. Maybe I can go further, but 12 volt is enough. If I can change the voltage maybe to 14 volts, I can use it for charging for 12 volt batteries or any other purpose. 12 volt power supplies can be used in many places. Okay, and it can also be changed to 24 volt power supply, which will be even more useful. But there was one problem. This main controller IC has some built-in feature of over voltage protection. When it goes above 22 volts, the output goes above 22 volts, it shuts down, and it's DAP026. maybe you can read it. And it's not a common standard controller IC. It's a custom made or application specific IC designed specifically for this power supply. I cannot find its data sheet, but it is basically a PFC controller plus a PWM controller combined. So in order to change the voltage, I need to modify this feedback mechanism. This whole thing is a feedback mechanism using LM393 IC. This is LM393, and these two optocouplers, one for the voltage and one for the current or overload. Maybe this is maybe for overload, current overload. I drew its schematic and let me show you. Okay, this is the schematic of this feedback mechanism only, not the whole power supply. It's feedback mechanism LM393 and these optocouplers, how this feedback mechanism is sent back to the primary side.